Alright, we've got a drive going. It's 257, I think, RPM. And it's 35 by 35. Chris is working on a lifty thingy. Alright, so this is the end of day one. We got the drive and the lift going. Have to add a flip out onto the end of there instead of the standoffs. And this gear has to be changed to a 84 tooth. Probably you're going to use 200, 1 to 7. And if that doesn't work, we'll use 100. Also, we're having some issues with the cartridges and the drive, so probably might have to take them out of the 15-inch. And then Chris made this cool lifty, extendy thingy that lifts, and while it does that. And then over there, he's working on a passive ring intake to go on to it. That will reach all the way up to the top pole. And a 6-motor drive. Yep, that's it for now. We have changed it to 1 to 7, and we're powering it from the back because it's cool, right?
No, it's ugly.
Intake. Yes, good. Alright, we're just about to have some food. Got the chain bar thing partially mounted. We've got a new powering thing. We're still missing another C channel on the other side of this, but now it looks like this, and it goes like that. So yeah, and Chris is working on the cool passive thing. Yeah, it's gonna use the forwards and backwards motion mixed with the up and down motion to do a bit of a different kind of passive intake. Okay, Chris has a thing. It's cool. Okay, and then there's the chain bar, but the chain broke for a reason. And then just hold button. And then we have an uneven 4-bar that tilts up as it goes so that the mobile goal doesn't fall off. Unstick lift. Lift is having some issues right now, but that's okay. So now the lift tilts upwards so the mobile goal doesn't fall out as it goes up. And it's cool. Yeah. That's it for now. He make a standoff. Yes. Mobile goal's gonna rotate over top of that. Alright, so this is the end of day 2. So we got the mobile goal thing, where it folds up like this and kind of stays in, and then doesn't catch, goes down with elastics like that. We've got the hip joint on the lift, 1 to 700 RPM, powering it underneath like that. And then we have, and this goes just above the platform, and it compensates for the mobile goal putting pressure on it because it is an uneven 4-bar. So this joint is in the corner there, so it tilts up as it goes up, which makes it work out quite nicely. And then over here we've got the cascade bar mounted now, and with the motor on it, it goes like that. And if we get this, then you can see just like that. And then the intake on it would be able to drop rings using pneumatics onto either of those and pick up rings on this side of the bot. Speaking of which, here's the ring intake, and as you can see, it's pretty cool. It's like that, and it also has this pneumatic release here to drop the rings. So it flips over when it goes up, so it's like kind of like dumping bots from Starstruck, but with rings. Yep, that's it for now. Okay, so we've got the tanks mounted on the bot now. We've got 2 of them, and we got a slider thing here. We're gonna have a thing you made of mobile. Show the mobile goal thing.
It's not done yet.
Show.
It's not done yet.
Show.
No, it's not even working.
Okay, well, I'll get another video then for that. Chris redid the thing. He redid it. It's not fancy anymore, but it's gonna be lighter because it'll be better if it's lighter. And then we have a piston here. We're trying to figure out how to make the piston strong enough to lift the mobile goal off the ground. And the lift is still the same. Okay, so we had this thing, and it was going to be powered by pneumatics and go like this and that, and it tilted the mobile goal over this standoff and lifted it off the ground. Like, and it went like this and lifted it completely off the ground with that hook. And that was, we had this slider and everything. It was mounted like this on the bot, and we were using the piston facing this way, which would, we'd have the string going to the piston. We had some pulleys, so the string went from like around here, in the background here, and then to the piston, and that was going to push. And then we had a floating pulley that increased the piston's force and all that stuff, and that was going to do that. But the ring intake, it was not inside 36 inches on the way up, so now we have to change it. And now the ring intake is going to go into this space, and we're going to put a standoff on the end of here that goes onto here and does the thing that that pneumatic mechanism would have done. So it'll be a whole bunch simpler, because that's what we got to do that. Yep. Which just sucks because Josh is working on a cool thing. Josh, let's skip to your thing that you were making. It's going to work differently, and actually, because this one was problematic because it required that it go in this length into the mobile goal before dropping in, so it used too much, like the pneumatics don't extend far enough for this, because you lose an inch of space here. It'd be better if it dropped in immediately here, and then it would have been better. So that's what Josh was working on, but now we're ditching that mechanism completely. So there you go, simpler. No! We have a tilty thing to make it stay in 36. So that's like not 36, and that's 36. And then when we go up, it goes, and then it can score on it better. Chris' idea. Actually, I don't know whose idea it was, but it's cool. Enough what matters. Unlike this mess of wires, but we're gonna ignore that. Okay, here's 5 rings. With more elastics, it works. Okay, wait. I know this won't work, so let's try it.
So I might have to assist the lift a bit.
Alright, that's fine. Because we need a tensioner. Let's go skip. Uh-oh. Yes. Pog! It freaking works. You know, that's pretty good. Look, it's Bear! Hi, Bear. How you doing? Alright, robot, go roboting. Yeah. We have a wire loom now, so it's less cursed. Oh no. Air gone. Sad. We have a tensioner now. That's cool. Whee! Yep. Fine. Go. No. Wait, lift up. Go. Shake. Shake bot. Like shake the bot, not the lift. Why does it not go, man? Alright, day 3 is finished. We're gonna just kind of have the chain skipping sometimes because we put in a good effort. We have an active tensioner, another tensioner, and it still skips at the very top sometimes, so that's just kind of how it is. We got a wire loom in there, we got the pneumatic grabby thing, and also it moves the thing to release it when it's upside down. It can also passively release the rings through this way if it's on a goal that's outside of the robot. We got the 4-bar with the uneven spacing so it tilts back when it lifts up. We got the tanks all mounted today. Moved the brain, got the brain and battery on in the first place, other tanks. Did some fix the drive axle so it fits in size. And yes, these do expand. It's just, it'll be fine. It's good, it works. And then this also expands, and it's great. There you go. So the robot is done, And we're probably gonna film the reel this week, maybe tomorrow. We'll see. So yeah, there's Bear. He wants to go to bed. So does Chris. And that's it. So we're about 3 days done. Kind of whack, but I think it's cool. Bye. Okay, so I'm gonna talk about the mobile goal stuff for the most part, because Chris did the ring stuff and the lift for the rings pretty much almost entirely by himself. So that was his thing, and the rest of us worked on this stuff more. So that's what I'm gonna touch on. So this mobile goal lift is meant to take mobile goals from the ground and drop them onto the platform. And of course you can carry a mobile goal around on it. Now, initially it was 1 to 500 RPM powered directly onto a brace going across the 4-bar. And so this was just screwed directly onto a brace. The problem with that, there were a couple problems with that. The brace interfered with the lift. If we put it in one place where it was convenient to do that from, another place that was convenient to do it from, it would stop the lift too early, so the lift didn't go high enough. We thought it was high enough, but then we checked and it actually wasn't high enough. So we ended up having to do a hip joint, and we put the gear and motor as low as possible, of course, with center of gravity, because if you're lifting, say, the tall goal outside of the robot at the front like this, it's like really bad for center of gravity. So we did what we could to help with that, like stuff like the pneumatic tanks and the brain and the battery all being back here helps with that as well. Now, initially as well, this 4-bar was normal, but you may have noticed that this 4-bar is now not normal, being that it is actually not even spacing. So instead of being screwed into this hole, it's actually screwed into that hole. And what that does is that as the 4-bar lifts, it also tilts back, which helps keep the mobile goal inside the lift and also compensates for any of the flex that we were dealing with these long channels holding the mobile goal. Now for expansion, what we ended up going with is we have a screw joint here, and then we have this coupler with a 90-degree gusset to help keep it in the correct position. And that is, it fits just around the channel it's mounted on. And then when it flips down, we have some aluminum 1x plate here to get it to stop the right location. And if it doesn't get stuck, boom, it stops there, and that's what keeps it in place. Now, for the lift as well, you'll notice we did something a little bit unusual for this kind of 4-bar. Like generally, this kind of weird. Like I wouldn't normally do this on a 4-bar, but yeah, we use standoff joints because it was the easiest and simplest way for us to get the spacing that we wanted here. Because initially we had the 4-bars mounted on the outside of this, but that caused problems with getting the mobile goal thing to work out nicely, and the powering and the bracing and all that stuff. So we ended up going with, okay, we put these bars all the way on the inside, then we do this, then we do this, and so we ended up doing that to get the right spacing. So that said as well, you can see this powered here, right through this, into the middle of the brace, which is boxed, because initially when we started testing it, this brace actually started bending since all the force was going right through the middle of it. So we ended up having to do that. And now, that's what's on this robot, but also there was originally planned to have 2 more mechanisms that are not here anymore. So, or at all, even in the case of the front one. So what we were going to do is have a pneumatic mechanism at the front and at the back to make the robot capable of properly carrying 3 mobile goals. Now, the back one we actually almost finished, but because of this not fitting in 36, which was an unexpected issue, we didn't think the 36 limit would actually be a problem. We had to completely get rid of it last minute. So what there was going to be is, let's see if I can lift this up. Oh yeah, that's another thing. You can't lift this without this being down, which is one limitation of our execution of this design. But if I lift the lift and plug it back in, we had to unplug it to prevent it from overheating, because I just used hold on it to keep it from falling down. So we had a linear slide here with the latch. Okay, so that was the latch, and that latch would have been on the slider here, and when it would go, latch into this mobile goal, and pull it up onto the pole like this, And you can see when it's on that standoff, it's not touching the ground, just barely. So, so long as I did that right, yeah. And then it just hits these 5 wides, and so it's held in nicely there, and the robot can carry it around without friction and all that stuff. And it would have worked too. We were worried about the strength of pneumatics, but after we did some testing with these, we realized that they totally would have been strong enough, which is a little bit unfortunate. But we simply did not have time to make it work with this. So there would have been a mobile goal here, and what we were going to do to power that system is we are either going to have a single pneumatic pushing the slider back, or we are also going to have a pneumatic, and we're using strings and pulleys to increase the amount of torque, or whatever word you want to use to describe that, because it's not rotational at the input and output, that the piston had. But when we did that, it reduced the displacement of the slider so much that it probably would not have worked. So we would have had to just go direct, but it probably would have worked anyway. Now, on the front, we were going to do something similar, but it probably would have had to drag the mobile goal on its corner, because there's not nearly as much space for a slider mechanism as there was on the back. So it would probably have had to have been like this, maybe like tilt the mobile goal a very tiny bit, because there's that gear right there, and would have been able to drag this mobile goal, carry the mobile goal in here, and lift a mobile goal in the back. And that's why we went through 6-motor drive, because of that initial design. Because we're like, we're not going to be able to do that without a 6-motor drive, probably. And even then, it can't actually go up the platform with 3 mobile goals. If it's pushing 2 of them, it's not strong enough. Too much, eh? So even with 6 motors at not that fast of a speed, I think it's 257 RPM, it's still not strong enough. But you can see here, so I can do a quick demonstration. So you can see how the forks flip down there, and then the robot. Now these have been bent a bunch from filming the reveal, so it might not work properly, but there you go. So you can see it's up. It was pushed down by the mobile goal a bit, so you can see that relative to this, it's kind of the C-channel, it's kind of angled down now, but it's still flat enough since the lift tilted this. You can see this C-channel is not vertical anymore, it's tilted backwards, and that helps with keeping the mobile goal on. And if I go, also that's a problem. So we didn't put grippy mat on it because we wanted to be able to slide under the mobile goals nicely if the clearance was too tight, but then because of that, you basically can't turn. Like, you can turn, but okay, that's about as fast as you can turn, probably. And then you go to the platform, and you just go. So we're going to go up to the thing, and you go. There you go. Got the mobile goal on the platform. And there's a couple things about this. So that works nicely by itself. But in skills, what you have is you would have a blue mobile goal, and you'll see this in the reveal, here on the platform. And that's not the color you want. So you'd go over there, grab a red mobile goal, and come over here and be like, no. And then there you go. And that's what we do. And then you would come over and, well, it depends which platform you want to park on. So if it's not the platform you want to park on, you just go ahead and dump a bunch of mobile goals on there. Now, if it is the platform you want to park on, so let's say you got rid of this, and then you're ready to park, you would not have this. What we wanted to do is you would actually put it on intentionally off balance, and then you would take this one and drive up with it in the lift, as you'd see in the reveal, and then that's how you get 2 over here, and you'd have to put the other 5, on that platform. Originally, what we wanted to do, which is why we wanted the 3 mobile goals in the bot, was to do 4 there, because it's much more easy to do, like, efficiently, and then just go up here with 3, and just hold them all. No fancy dropping on the platform business, because that takes longer to do, but this is the result we ended up going with. Also, I would like to mention a robot idea based on this. What you could do, I think, is if you wanted to ditch rings, say for an earlier season design, just not do rings at all, though I think this is a good proof of concept to show that you can do rings on the tall goal with only 1 motor for them. What you could do instead is you could have this one, and then just copy paste it onto the back of the bot, and then have the pneumatic latches I was talking about there and there, and then you carry alliance mobile goals on top of each other, or an alliance mobile goal underneath a neutral goal. So if you do this, you can see it like just barely clears. So if you do this, make the lift go, the lift's not even all the way up. Actually, it is. But if you make the lift go a little bit higher, and you could carry 4 mobile goals at once, and then, I don't know, that could be handy for skills, I imagine. I haven't actually thought about it too much, but it's an idea. So if you wanted to carry 4 mobile goals using 2 motors from the mobile goals and 6 motor drive, there you go. That's an option, I suppose. But long term, I don't think it'd be very viable because you'd need the points from rings eventually in skills. So yeah, I think that's about it for the mobile goal stuff, and why we went for the drive. We wanted the torque for the platform and such. We're actually originally going to go for like, it was like 430, I think. We're going to do 5 to 7 instead of 3 to 7, but like the other guys wanted to do that, and I was, no, it was needed because we needed that for the platform, and even then that wasn't enough. But yeah, I think that's going to be about it. So yeah, thanks for watching, and that's it for my part of the explanation for this robot.
Hey, Chris from Team NXS here. For this robot, I was in charge of designing the ring scoring system. Our strategy going into this was have a robot that could score all of the mobile goals and get 8 rings total on the tall pulls and skills, while also having a robot that would be competitive in standard matches, with the side goal of proving that you can internally stack on the high pulls while having a 6 motor base. The goal when making the lift was to have a design that allowed for both horizontal and vertical movement with just 1 motor and 1 pneumatic piston. An alternative design could have been to use a double reverse 4-bar and a piston for horizontal translation. This would have also allowed for internal scoring on the lower pulls if the mobile goal was aligned correctly, but we decided to go for the cascade bar lift because I wanted to try something new, and otherwise I probably would never have a reason to build this type of lift. A 1-motor cascade bar works similarly to a standard cascade lift, except instead of having the bottom stage of the lift fixed to the base and powering a sprocket on it to raise the lift, the sprocket is geared to a fixed gear on the base, and the entire lift is rotated around the gear. With our design, the second stage of the lift is screwed onto the chain, causing the second stage to rise as the chain is turned. This should fit well within the 36-inch limit, as the lift can be short when it's horizontal and long when it's vertical, if geared correctly. But the mobile goal forks were longer than I had anticipated, which forced us to redirect time away from the tuning and making the mobile goal latches. This also meant using both pneumatic cylinders on the ring system, which we were hoping not to do. Ultimately, this lift is very much a prototype and is currently not competitively viable. The main issue is that if the chain or the gears skip, it allows the slider to drop down, and this shortens the max height of the lift. As well, the VEX sliders use steel rails, which are quite heavy relative to the aluminum, and they can have a great deal of friction in them. To optimize this design, it'd probably be best to have 2 bars, one on either side of the intake, and use custom sliders. Our initial plan for the ring intake was to have a passive intaking action and an active release so that it could dump the rings onto either high pull. Because the intake was flipped upside down when releasing, using a plunger style intake wouldn't work unless the entire plunger was able to flip around, so we went with a claw and hopper combination intake. I experimented with using fixed flaps to hold onto the rings when the intake is pushed down on them, but it quickly started to take more tuning than I'd have time to do. The next design was to passively actuate a claw using the vertical and horizontal movements of the lift and robot. I had designed a mechanism that would hit the ground before the claw, and push out the claws as the intake was pushed down further. To close the claws onto the ring, the robot would drive forward slightly, which would push the angled pieces on the passive mechanism away from the claws, and would let the elastics on the claw shut it close. Prototype for this design was too heavy and required more force than the lift could provide, so I switched to an active claw design that used pneumatics to both open the claw and open the top of the hopper at the same time. The front of the hopper has a gap in it, allowing for scoring on the neutral and alliance goals. To further optimize the intake, I put angled liners sticking down through the claws to push the ring into the center, and then would also stop the intake at the right height so that the claws can close without hitting the tiles. The other main issue with the intake was that it was extremely tricky to align it with the high poles, and it definitely needs some sort of aligner if it was going to be used in an actual competition. Thanks for watching, and I'll see you next time.